So this exercise is the classified wave questions. The question one we did yesterday. So we'll start with the next question, page 7. The questions are not in order because from different past papers, these questions are cropped. So you don't find the order of the question number correct. That's according to the past exam papers. So page 7, a horizontal string is stretched between the two fixed points A and B. So there's a string which is stretched between the 2 points A and B. The vibrator is used to oscillate the string and produce an observable standing or a stationary wave. At one instant, the moving string is straight as shown. So the point P is there and from A to B is a string length. The dot in the diagram represent the positions of the nodes on the string. Like this is a node, this is a node. So these are representing the nodes. The wave of this on the string has a speed of 35 meters per second with a period of 0.04. Like in 0.04 seconds, it complete one oscillation. What does it mean? One oscillation, like example, as you see point P here, like this is the position. So next position, it will be like this, goes down. Next position, it will again come back to same place. Next position, it will goes up. And the next position, it will come back to the same place. Like going down, coming back up, then going up and coming back down. That is one complete oscillation or one vibration. So that duration or that interval is 0.04 seconds. So in 0.04 second, it completes this motion. Explain how a stationary wave is formed in the string. This is a very common question, a structure answer you have to learn. The formation of a standing or a stationary wave when two progressive waves are there which are traveling in opposite direction, it will always result in a formation of a standing wave. So as I mentioned, you have to learn the structure answer for this. So your answer should be structured. You'll mention two progressive waves traveling in opposite direction. It is important to mention that the waves are traveling in opposite direction because if two waves are traveling in same direction, they might interfere, but they will not result in a formation of a standing wave. So two progressive waves moving in opposite directions give rise to meet each other or superimpose, give rise to standing wave. That's the structure answer. And the formation of the nodes and antinodes is because when two waves cancel out the effect of each other, we got nodes, as you can see here, these points. And the place where two waves can increases the effect of each other, we get antinodes. Superpose or superimpose, that's the same thing. The next is on the figure 5.1, sketch the line to show the position of the string the quarter of a cycle later. Means after, as I mentioned just now, I drew that after, if one complete time period is t, and the original position is shown here like this. So after quarter, what will the new position? The new position will be like this. This will be t by 4. Then after half, if they say sketch the position of the string at a half cycle. So after half cycle, string will be at the center position. Then if you want to sketch a position after 3 by 4 of the time period, so this will be the position. If you want to sketch a position after time period, so it will return back. So this will be the position t. So we just want to sketch the position. Antinode is a point where the two waves meet and increases the effect of each other. But the wave does not stop oscillating because like if this was a string, how it will look like this. This is after, in the question they mentioned at the instant the moving string. The string is moving. It is straight. What will the new position? And the point P they mentioned it is going downward. So what will the new position? The new position will be like this. This will be the position of the wave after quarter of the cycle. What will the position of the string after half cycle, like T by 2? The string will return back to the same place. Then what will be the position of the string after 3 by 4 of the cycle? So this will be the new position of the string. And what is the position of the string after complete cycle? So it will be at this position. But because it is vibrating, as it is vibrating, so it goes down, come up towards the mean position, then goes up and coming down. But the position, these points are called anti-node where we have a maximum amplitude. And these points are nodes where we have a minimum amplitude. The position of the nodes and anti-nodes does not change throughout the vibration. So we want to just sketch the position of the string after quarter of the cycle. So after quarter of the cycle, this will be the new position of the string. When we draw a standing wave, usually how we draw a standing wave, we draw like this. So what is the reason why we draw the standing wave in this manner? Because the string is vibrating, the position is not fixed. So it might be down, it might be up. That's why we draw the standing wave in this manner. But the string itself cannot be at two positions at the same time. Either it will be down, either it will be up, or either it will be at the center when we are observing. So if they ask sketch the quarter of the cycle as and the point P is moving downward that they mentioned, so this will be the new position. Is it clear? This is sketch. Anyone having a doubt or a question in this? Okay. Determine the horizontal distance from A to B. So if you want to determine the horizontal distance between from A to B, this is a node, this is also a node, this is also a node. So all of them are nodes. The points they already mentioned in the question. What is the distance between the three successive nodes? The distance between the three successive nodes is one wavelength. This is also one wavelength. And this is what between the two successive nodes is half a wavelength. So what is this total distance from A to B? The total distance is actually equals to 2.5 wavelengths. So first we have the speed and we have the time period. We can work out the wavelength. How to work out the wavelength? V is equals to F lambda. So V is equals to F lambda. V is a speed which is 35. The frequency is not known, but the time period is known. So we can take the reciprocal of the time period to know the frequency. 1 over T is equals to F. So in place of frequency, we can substitute 1 over time period. So it will be 1 divided by 0.04 and the wavelength is not known. 0.04 is divided, other side multiplied. So 35 times 0.04. What's the answer? 1.4. Okay. So the wavelength is 1.4 meters. But the question was determine the distance between A and B. Between A and B, in terms of the wavelength, the distance is 2.5 wavelength. So the wavelength is 1.4. So 2.5 times 1.4. What is the length of this string or the distance from A to B? So it is equals to 3.5 meters. Yes. Is it clear? The next we have particle on a string has a zero displacement at time t is equals to 0. From t is equals to 0 to t is equals to 0.067, the particle moved through a distance of 72 millimeter. Calculate the amplitude of oscillating particle, of the oscillating particle. So we want to determine 0.06, okay. So time period is 0.04. And we want to determine the amplitude at the time 0.06 seconds. So how many oscillations are there? Like if the time period is 0.04 second and we want to know the number of oscillation or number of vibration it does. So how many vibrations will be there? 0.06 in 0.06 second, how many oscillation divided by time period? So 0.06 divided by 0.04. So we got 1.5 oscillation, like 1.5 vibration. So means this particle, the particle here will go down, then come back up, then goes up, come down. That is one oscillation. Then again, because 6, this is one oscillation, we want 1.5. So then it goes down and come back up. So how many total distance, because this total distance in the question it is given that this total distance is 72 centimeter. So if this total distance is 72 centimeter, what is the amplitude? How we will work out what is the amplitude here? No, amplitude is a maximum displacement. The particle P in 0.06 second, we work out how much distance it cover. So the total distance with this particle covered, that this total distance is 72 centimeter. And how many times this particle has moved in this 72 centimeter? How many times this particle has moved in 0.06 seconds? So it has moved 6 times. So 72 divided by 6. So we'll know the length of each or the distance covered in each one. So 72 divided by 6, what's the answer? So the answer will be 12. This was in millimeter. I guess it was in millimeter because centimeter is a large unit for the amplitude of this particle. So this will be 12 millimeter. So means the amplitude or the distance of one time is equals to 12 millimeter. Is it clear? Amplitude is the maximum displacement which the particle cover. So after 1.5 vibration, the particle will be there at the center. Like particle move up, like goes down, as they mentioned. The particle P goes down, then it comes up, then goes up, come down. That is one oscillation. Then again it will go down and come back to the center position. The particle P at this point at a time 0.06 second, that is at the center position. But the question is not what is the position of the particle. The question is what is the amplitude. Amplitude is a maximum displacement. So for this 6 intervals, like 6 sets of motion, the total distance which the particle cover was 72. So 72 divided by 6, we got 12 millimeter. So each distance is 12 millimeter, or we can say the maximum displacement is 12 millimeter, which is the right answer. The next question, it's related to the Doppler's effect. As you can see, the motion. By reference to the direction of a by reference to the direction of transfer of energy, state what is meant by a longitudinal wave. So in terms of transfer of energy, how we define the term longitudinal wave? Longitudinal wave is actually a wave in which the particle vibrate or the direction of energy transfer is parallel to direction of wave. So direction of the particle vibration is same as the direction of energy transfer. The next is a vehicle travel at a constant speed around a wide circular track. It continuously sounds its horn, which emits a signal of a frequency 1.2 kilohertz. An observer is a large distance away from the track as shown in the view from the above 4.1. The direction of the travel is shown like this is the direction in which the vehicle is moving. So what will happen? This is actually a Doppler effect as the vehicle is approaching, like moving closer. So the receive frequency, like it is emitting 1.2 kilohertz, but what is received will be higher frequency. It will be more than 1.2 kilohertz. That is the Doppler shift. Same thing as the vehicle move away. So what will happen? It is emitting out the same 1.2, but what is received by the observer as it move, it will be longer wavelength or a shorter frequency. So it will be less than 1.2 kilohertz. And when approximate, like when the vehicle in this section, these two sections, approximately the distance does not change, a negligible change in the distance. So in that case, what is emitted by the vehicle, because the relative position is not changing, distance is not changing. So what is emitted by the vehicle, same frequencies heard by the observer or recorded by the observer. The graph is given to us, the variation of a frequency. As you can see, the frequency, the maximum frequency which we receive is 1.2 and the minimum is about 10 boxes equals to 0.2. So each is 0.02. So this is 1.02, 1.04. So higher frequency when the vehicle in this section. When the vehicle is moving towards, the frequency is higher. When the vehicle is moving away, the frequency is decreasing, like it is getting less than this section. If I draw, when it is approaching, this is the section, the higher frequency. And when it is moving away, this will be the frequency is less than what is emitted out. Receiver frequency is different. Explain why the frequency of a sound detected by the observer is sometimes above and sometimes below 1.2 kilohertz. So what is the reason why we are receiving the frequency sometime above to 1.2 and sometime below? So the frequency of the source is not changing. That is always the first point. The frequency of a source does not change, but the observed frequency changes due to the relative motion of the source. So the frequency is varying because the vehicle is moving relative to the stationary observer. So when the vehicle is moving towards the observer, it will give a higher observed frequency, higher than 1.2. And if it is moving away from the observer, it is giving less than 1.2 kilohertz. Then state the name for this phenomena in B1. What we call this? We call that as a Doppler's effect. On the figure 4.1, mark with the letter X the position of a vehicle when it emits the sound that is detected at time t. So at time t, we are observing a higher frequency. Means more than the actual value. So if you are observing more than the actual value, what should be the position? So we can mark the position X here. Anywhere in this section we can mark. But that is a maximum increase is there. As the vehicle is approaching, it is moving closer. When the object is moving closer, what will happen to the frequency? The observed frequency will increase. So in this section of a track, we can mark X. Then the next part, as the frequency is maximum there, on a figure 4.1, mark with letter Y the position of a vehicle when emits a sound at which is detected at a time 9t by 4. Means 9t by 4 means about 2.25. So 2.25 will be, this is 2.5. So 2.25 will be here. And at 2.25, it is 1.2. If you are receiving 1.2, what will be the likely position? So means because X we already marked here. X we already marked here. So what will be the position of a Y? The position of Y will be here in this section. Why I did not mark Y on this section? I can mark here as well. But because it's a continuation, as I mentioned, the direction in which the vehicle is moving. So if X we mark here, the new position Y will be at this place. And it is like if this was X, after completing another cycle, it will be at this position X. Then after completing another cycle, it will be X as well. No, it cannot be another position. If you see the question, at time t, we mark the position X here. Then at time 2t, it will be again at X because after completing another cycle, it will be at X again. Then after, at time 2.5t, it will be here. And at time 2.25t, so at 2.25t, it will be here. If they say position at 2.75t, then what will the position? Then this will be the position. So after t and 2t, it is in the same place. Then after 2.25, then 2.5, 2.75, and then after 3t, it will be here. So that's why the position of a y we label on this section. I'm saying y can be in this section as well because both ways it will be 1.2 kilohertz. But according to the question, it cannot be at on the left. It is on the right hand side. According to the cycle, the time period of the cycle which is given. The speed of a sound in air is 320 meters per second on a figure. Determine the speed of the vehicle. So if you want to determine the speed of a vehicle, we can use any one of the frequency. We can use a higher frequency or a lower frequency. Higher maximum and the low, but the Doppler formula we have to use, the Doppler effect formula, that if you use the observe, because the F naught or the observed frequency is equals to, you can also use 1.2, it will give the same result, but the formula will change according to if you are using 1. The two possibles are there. You cannot use 1.2. Why you cannot use 1.2? Because 1.2 is not a Doppler effect. Doppler effect is a relative change in frequency when the source and observer are moving relative to each other. So if you use 1.2, that will not give you result. So the maximum frequency which is observed, like the observed frequency, is equals to the formula of the Doppler. The speed is given. So the observed frequency is equals to original frequency times the speed of a wave divided by the speed of the, if we are subtracting, so this will be speed of the wave minus the speed of the source. This is a formula if we are using that the frequency observed is increased, higher frequency. Then V minus V over Vs into F naught. F naught is a original frequency which is emitted out from the source. V is the speed of the wave and Vs is the speed of the source. But if we are using a minimum value for the frequency, the lower frequency, so the formula will be V divided by V plus Vs into F naught. So any one of them you can use a minimum value of the frequency or you can use a maximum. If you use a maximum value of the frequency, then you will use this formula. If a minimum value, you will use the other formula. So if I'm using a maximum value, like it is 1.4 kilohertz, so I'll substitute this as 1.4 exponent 3. The speed of the wave, that is 320, and original frequency was 1.2 kilohertz divided by the speed of the wave, which is 320 minus speed of the source. Now we cross multiply. So 320 minus Vs is equals to 320 times 1.2 exponent 3 divided by 1.4 exponent 3. Exponent 3 will cancel with exponent 3. If we need Vs, we just move Vs here. What's the answer? The final answer for the speed of the wave? Speed of the source actually, not the wave. At what speed the vehicle is moving? 45.7. Okay, good. So speed of the vehicle is 45.7 meters per second. You can keep it in the 3 significant figure or you can round off to 46, but 45.7 meters per second. So if you use a higher frequency than this formula, lower frequency, the other formula. And your course outline does not have a motion of the observer. Actually, observer can also move, but your course outline, you will always have a motion of the source. Like always, the source is moving either towards observer or away from observer. That's why you have to memorize this formula. Next, we have state the principle of superposition. What is the superposition principle? That it is state again whenever any principle or a statement or a definition is there, try to learn the standard definitions, standard statements. Don't try to write any definition or a law in your own words. So when two or more waves will meet at a certain point, the resultant displacement will be equals to sum of individual displacements. So the principle of superposition state that when two or more waves meet at a certain point, the resultant displacement of a wave is equals to sum of individual displacement. That's a superposition principle. The micro transmitter produce a microwave that travel in air towards a metal plate, and as shown. So microwave transmitter is there, and so what actually happened, the microwave transmitter sent the microwave and it hit the metal plate and bounced back. So two waves which are traveling in opposite direction, what it will give? It will give rise to a standing wave. So in this region, we'll have a standing wave. We will have a pattern of a nodes and antinodes. And how we confirm that there is a node and antinode? So we have a microwave receiver is there. Some places this microwave receiver will record a high intensity microwave, and some places it will record no microwaves, means nodes will be there. The microwave has a wavelength of 0.04 meters. A stationary wave is formed between the transmitter and the plate. Explain the function of the metal plate. What is the function of the metal plate here? The metal plate is actually used to reflect the microwave so that the waves can interfere and give rise to a standing wave. So the metal plate is actually reflecting the wave. That's the one, yeah, reflecting the wave. That's the answer. Next is calculate the frequency in gigahertz for the microwave. We have the wavelength and we know it's an electromagnetic wave. So these electromagnetic waves, they travel at a speed of 3 exponent 8 meters per second. So use a formula V is equals to F lambda. So 3 into 10 to the power 8. F is a frequency. which is unknown, and the wavelength is 0.04. So 3 exponent 8 divided by 0.04. What's the answer of the frequency? 7.5 exponent 9. So the frequency is 7.5 exponent 9. And exponent 9 is known as what? It's known as a giga. So we can say it's 7.5 gigahertz. The prefixes, that's the first topic, like kilo, mega, giga, tera. A microwave receiver is initially placed at position X, where it detects the intensity of minima, like minimum is recorded there. Means that there's a node. The receiver is then slowly moved away from X directly towards the plate and determine the shortest distance from X when it detects another minima. So let's say the node is formed here and we are moving this X to a new position. So that we get another minima. So what is the distance between the two successive nodes? The distance between the two successive nodes in terms of wavelength, it is half of wavelength, lambda by 2. So we want a minimum distance here, like distance between the two successive nodes. So this distance, when it moves, it will be lambda by 2. Lambda is a wavelength, so it is 0.04. So 0.04 divided by 2, we got 0.02 meter. So 0.02 meter will be the minimum distance which we can have between the two nodes, because it's a half of the wavelength, or the distance from one node to another. Determine the number of the intensity maxima that can be detected as it moved from X to a position 9.1 centimeter away. So distance between the maximas or the minima will be same as 0.02. So how many are possible here? If we move this X to a distance of 9.1 centimeter or 0.09 meter, 0.091 meter. So in 0.091 meter, how many nodes we will have? So the minimum is 0.091 divided by 0.02. What's the answer for this? Because the distance between the two successive nodes is 0. So about 4.55. But if you see, they're asking how many maximas are there. Like if we have this we detected node, then another node is there 0.02 meter, then another node is there 0.02 meter, then another node is there 0.02 meter, another node is there, because we want the total length to be moved about 0.91 0.091. So means like we have to move about 4.5 times. So 1, 2, 3, 4, like 1, 2, 3, 4, and then 0.01. Like this distance will be 0, because 0.02, 0.02, 0.02, 0.02, and 0.0. What will the total distance move? It will be 0.09 meters. The question is how many maximas are there? They did not ask. So this will be antinode, this will be antinode, this will be antinode, this will be antinode, and this will also be antinode. So how many antinodes we will see or are recorded? So how many antinodes will be recorded here? So maximum will get 5 antinodes. And how many nodes will be recorded? So 1, 2, 3, and 4 nodes will be recorded. Is it clear? Because between the two nodes, we will have empty node. What about the fifth node? No, there will be no node because we did not move the distance. No, ignore 5 nodes from the beginning. If you begin from this one, including this, yes, 5 will be there. But after moving a distance, that excluding the first one, because we exclude this one, we detected antinode, then node, antinode, then node, antinode, then node, antinode, node, and then we move a distance of 0.9. We stopped at antinode. We will not record the node after that because we stopped here, the detector. Is it clear, this question? So the question was determine the number of intensity maximas. Like how many maximas are detected as it moves from X to a position 9.1 centimeter away from X. So actually how many nodes it will be there? Like at a distance it will be 4.5. So 4 of them nodes and then an anti-node will also be there. That's why when we stop at 9.1 centimeter, we'll not record the minima, we'll record the maxima. Because the distance between the two successive, like one node and anti-node, that is quarter of the wavelength. How we got 2 marks? It's 1 mark is from showing the spacing. What is 4.55 is like how many times we are moving. 4.5 is representing the motion. So this was node, 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 and then we label the position antinodes. 1 mark is for the answer. And why it is of 2 marks? This part, these two combined, this is having 1 mark, this is also having 1 mark. So there is no working you have to show. You just directly write the answer for this. Is it clear? These questions?